The first talk that I'd like to highlight is the idea of being able to gather lots of atoms together in a cold sample in a vacuum chamber, where if you excite one of the atoms into a Rydberg state, it will prevent all the other atoms in the cloud from absorbing photons. And this is going to be a key technology in trying to realize scalable quantum computation. So this is a very exciting result. There are now many groups around the world that are working on this, and we'll be hearing many reports of this at the meeting. Another hot topic at the meeting this year is the development of chip-scale microfluidic devices that will allow for sensing of proteins and other biologically important materials in a very tiny sample, in picoliter type samples. And what's most interesting is that these are becoming so developed now that we can identify proteins even in the case where the sample is quite contaminated, and that we have very good selectivity from one type of molecule protein to another. Another area that's a hot topic this year is the development of what are called attosecond pulses, and using what's called the atto-clock technique to really be able to resolve in real time the dynamics of an electron as it's being ionized from an atom. One example is tearing off an electron from a helium atom. We now have such exquisite measurement control over that process that we can realize that the electron doesn't fly away immediately from the helium atom, and that the process of tunneling as the field is ripping the electron off from the atom actually takes some time, and that's a surprising result.